Okay, so we are going to talk about antioxidants. And I'm sure by now you have heard about antioxidants. You see it on all the little packages full of antioxidants. And you're like, okay, that must be good stuff. But you're not really sure why it's good stuff or what it does or why you need it. So that's what we're going to talk about today. And to get us there, we have to go into a little bit of chemistry. But don't worry. Don't freak out. It'll be easy. It'll be simple. No worries. We're going to start out with atoms. Yeah. Oxygen atom to be specific. And this oxygen atom, if you look at my lovely little picture there, yeah, I did not go to art school. Here is our oxygen atom. It has 8 protons in the middle in the nucleus, and protons are positively charged, and so you want to balance that out, right? They need to be balanced. So you are going to balance it out with electrons. And if you see floating around the nucleus, you have 8 little electrons, those little green guys. In the inner circle are 2. The inner circle can only hold 2 electrons, so that circle is full. And then on the outer circle, you have 6. So that brings you to your 8 electrons. However, the outer circle can hold 8 electrons, so it's not full, which means this little oxygen atom is running around looking for 2 more electrons to fill up its outer circle, its valence circle, valence level. So what it does is it bonds with 2 hydrogen atoms, H2O, so you have water there, and it gets its 2 electrons and everybody's happy. Or it can bond with another oxygen atom to make an oxygen molecule, and then it's got its 2 extra little electrons here to fill up its outer circle, and then it's happy there. So let me show you what I'm talking about. Here we have a picture of a happy little molecule. When 2 atoms get bonded together, they are called molecules. So these 2 oxygen atoms, they bonded together, and now you can see that they have 8 little electrons in their outer ring, and they are happy. See, there's 4 electrons bonding them together, and then you've got 2 sitting up here and 2 sitting over here. So they have 8 each. So this is a happy molecule. It is stable. It's going to just float around as a happy little oxygen molecule, no problems. However, sometimes this valence level, this outer ring, it doesn't get full of its 8 electrons, and that can be where the problem comes in. That's when we get an angry molecule. See, it's angry because its outer circle, its valence level is not full. It's missing 1. It only has 7. See, only 7. It's missing 1. So it's angry. So what is that molecule going to do? It's going to float around, and it is going to start stealing electrons from wherever it can. It steals it from other weaker molecules and adds it to its own little plate. Now, antioxidants are important because these angry little molecules that are running around stealing electrons, those are called free radicals, and they are bad because free radicals are stealing electrons from other molecules in your body, which can disrupt your cell membranes. It can mess with your DNA, because once a free radical steals an electron from another molecule so that it can be a happy molecule, it has just created another free radical. It's kind of like a chain of events, you know? So eventually it gets to the point where some molecule is going to steal an electron and cause instability in your cellular membrane so that your cells don't work correctly, or even worse, from your DNA, which we don't want to mess with because it's DNA. So how do we solve this problem of all these free radicals, these angry molecules running around? Well, your body already has a system for that, and it's called antioxidants. Vitamin C, vitamin E, beta carotene, those are some examples of antioxidants. And what they do is they donate an electron right here to this angry molecule. They make it happy and stable without becoming free radicals themselves. So how do you get all these antioxidants? You eat your fruits and vegetables, people. Eat your fruits and vegetables. But some of us are not very good at eating fruits and vegetables. Or we don't eat the right kinds of fruits and vegetables, like the leafy greens and all of that, carrots and all of that stuff. So we need a little help. That's where we need the antioxidants in stuff like Ninja. Can you tell I have an addiction? So Ninja Red is an antioxidant-packed little drink. It's made from wolfberries mainly, and it's got blueberries and prunes and other juices in there, plus essential oils. So what it does is the antioxidants in this juice go in and they add that little electron into your angry molecules, your free radicals, so that your free radicals will stop disrupting your system. Free radicals have been linked to things like cancer, heart disease, eye macular degeneration, like all kinds of bad things that you don't want to happen in your body. And if you're not eating your fruits and vegetables like you're supposed to and supplying your body with lots of antioxidants naturally, then you need some extra help, and Ninja Red can help you do that. Something to keep in mind, couch potatoes. For people who are doing workouts all the time and your body has gotten used to it, this isn't so much of a problem. But for people who are just starting out with workouts, like weekend warriors or people who are just starting out, when you start working out, you start breaking down a bunch of fuel for your body to get energy, and some of the byproducts of that are free radicals. So when you start working out for the first time and you're going hard at it, you are like flooding your body with free radicals that your body hasn't kind of built up that antioxidant system for, since you haven't made a continuous habit of exercise. So it's really important when you first start out with exercising that you load up on antioxidants. And this is a great way to do it. You just need one little shot per day, 1 ounce, 2 ounces per day, and you're good to go. So those are antioxidants, free radicals. We do not want angry molecules in our body. We want happy ones, and Ninja Red can help you get that. Okay, back to class.